All right, in this first example here, write 0.8 or 8/10 as a fraction. Well, 8 over 10. And then, of course, reduce. 2 goes into both of those, so 4 over 5. And there's the fraction for the decimal, 8/10. Now, it gets complicated when you have a bar for the repeating part of the decimal. How do you get the fraction for that? For example, 0.8 repeating can't be 8 over 10. Could it be 8 over 10? Could it be 88 over 100? Could it be 888 over 1,000? All of those fractions reduced would give you different fractions. So how do you find the exact fraction that represents 0.8 repeating? Very simple method. First thing you do is you let n equal 0.8. Then you have some choices. I want you to think. If one number repeats, then you're going to use 10n. If two numbers repeat, you're going to use 100n. If three numbers repeat, you might need to use 1,000n, and so on. That's the pattern that becomes important here. So, for 0.08, when the 8 is repeating, that's a repeat of one decimal place, so I'm going to use 10n, and I'm going to do a subtraction problem. I'm going to take that n, I multiplied it by 10, write 10n. Take 0.8, repeating, and multiply it by 10. I get 8 point, the 8 was repeating. Since it's repeating, I cannot put a 0 there. I have to put what the repeat is. So it is an 8. Be careful on that part. Never put zeros up here. Now, unless, of course, the 0 was repeating. Now you're going to do a simple subtraction. 10n, take away 1n. 9n. That was pretty easy. 9n, equal sign. 8.8, take away 0.8. Now remember, this is repeating, so that means 8 would go on forever there, and the same here. So no matter how many 8s I write on the bottom, I would have just as many on top. When I subtract, those would cancel out. So I really just have to subtract this part here. 8.8, take away 0.8 is 8. Then divide by 9, so I get n equals 8/9. So the fraction 8/9 gives you 0.8 repeating. You can, of course, check that with your calculator. Okay, let's try the next one. This one has 0.08 repeating. So again, let n equal 0.08. Since 0.8 is repeating, should I choose 10n, 100n, 1,000n? What do you think? I hope you chose 100n. 2 repeats, 2 zeros is one way to remember it. So I'm going to put 100n up here, equals, I need to multiply this by 100, which is really move the decimal point 2 places, so it's going to be 8 point, and I have to put numbers after that decimal point. Should I just put in zeros? No. What repeats? 08, so I would put 08, 08 on forever if I wanted. Don't need to. Now I'm going to subtract 100n, take away n. 99n. Okay, what's next? Subtract this part here. 8.08, take away 0.08, 8. Divide both sides by 99, n equals 8 over 99. Now I can check to see if I get, if I can reduce that, but hopefully you realize that that does not reduce. All right, let's follow with a few more examples. How about this one, 0.08? So n equals 0.08. Just the 8 is repeating. So do I do 100n because it's 2 places after the decimal point? No. I do 10n because 1 place repeats. So 10n equals, multiply this by 10. So that would be 0.10 8 repeating. Now, again, I have to do a subtraction. I need a placeholder there. Should I put a 0 or should I put an 8? Think carefully. 8 repeats, so I have to put an 8 there. Okay, let's do the subtraction. 10 in, take away 1 in, 9 in. 0.88, take away 0.8, 0.8. Divide by 9, n equals 0.8 over 9, which equals 8 over 90. And then I can reduce that, and what do I get? 4 over 45. So that's the answer for that one. Okay, let's do one more of these. How about this one? N equals 1.101. 3-number repeat. Do I use 10 in, 100 in, 1,000 in? What do you think? 3 numbers repeat, use 1,000. 1,000 n equals, that means I have to multiply this by 1,000. 3 decimal places, so 1101 point. Let's fix this so that everything lines up properly. So let's move this over. 0.101, it was 1.101. What do I put here? Zeros? What was repeating? The 101 was repeating. So 101. All right, let's subtract. 999n equals 1100. That's 0. All right, divide both sides by 999. So n equals, and can I reduce that? Nope. You can check it with your graphing calculator if you're not sure. Now, another thing you had to do on this section was find rational and irrational numbers between a pair. For example, if I had to do a number between 0.1 and 0.2, first thing you want to do is think about these two numbers. I need something between them. Well, add another decimal place. Now there's lots of numbers between them. If I want a rational number between them, I could do 0.11 or 0.12 or 0.13. If I want an irrational number between there, what should I do? Just make up any number. 1, 1, 2, 3, 1, 5, 6, 3, 2, 1. Anything that does not have a specific repeat, and put 3 dots at the end of it so that it goes on forever with no repeat. This one's rational, this one's irrational. And both are between that. So you can add decimal places to numbers. If they give you some numbers that are in radicals, like root 6, and I need a number between root 6 and root 7, you could find the decimal for this and find the decimal for this, and then find 2 numbers in between. So, good luck.